So the quadratic formula doesn't always give you nice perfect whole number answers like day one. So we need to make sure that we know how to fully simplify our quadratic formula answers when they're a little more complicated. So we're going to reduce these three fractions really quick before we go to more traditional looking quadratic formula questions. So when you're left with sort of a crazy fraction like this, where you have two terms up in the top numerator, the last step in simplifying is asking yourself, is there a common factor with every single number that you see out there? Which just means, is there a number I can divide everything and get a perfect whole number? Where I know that 2 is a factor of all of these, I can divide all of these numbers by 2 and get a perfect answer. 6 divided by 2 is 3. 4 divided by 2 is 2. And 12 divided by 2 is 6. Now these do not have a common factor anymore. Even though 3 and 6 can be divided by 3, and 3 and 2 can be divided by 2, all three of the numbers cannot be divided by the same factor, so we're fully simplified. Once again, what's the biggest number where we can divide all the numbers we see and get a perfect answer? Well, I know I can divide everything here by 4. 4x divided by 4 is just x. 16 divided by 4 is 4. 8 divided by 4 is 2. Now, 4 and 2 have a common factor, but remember, there's a hidden 1 out front of this x, and 2 is not a common factor for all three of them, so we're done. So what's the common factor we can divide? Looks like 5 is going to work here. 5 divided by 5 is 1. 25 divided by 5 is going to be 5x. 10 divided by 5 is 2. No more common factors. That's going to be bring this thinking to quadratic formula type answers. So after you've plugged in your a, b, and c, and you've gotten one number underneath the square root, like the square root of 5, square root of 20, square root of 250, you have to ask yourself, can I simplify? But when we have the square root, it's going to be a little bit different than those fractions we were just discussing. When we ask ourselves if we can simplify, we are only going to look at the numbers that are on the outside of the square root. So we're going to ignore any number underneath the square root for now. We're only going to ask ourselves, can I divide all of the numbers that have escaped by the same factor? In this case, it looks like 3 can work. 3 divided by 3 is just 1. 6 divided by 3 is 2. We never touch the square root of 5 with this step. 12 divided by 3 is 4. That would be my final correct answer. So over here, sometimes students get a little bit tricked up. They see that, oh, there's a common factor. I can divide everything here by 2 or even 4. But remember, we can only do this math with the numbers on the outside. And if you don't see a number here, we assume there's a 1. So even though 12 and 8 have common factors, 12, 8, and 1 do not. So before you can try to do that simplifying step, you have to check if you can reduce your radical anymore. So right here, I know that 20 can be broken down into 2 times 10. 10 can go into 2 times 5. I see here that I have a pair of 2's that can escape, and then a 5 will stay in here. So I can rewrite this as when I have a pair, 1 dies, 1 escapes. The 5 doesn't have anywhere else to go, and that's still all over 8. So after you reduce the radical, now we can check, do these three numbers have a common factor? And yes, we can divide everything by 2. 12 divided by 2 is 6. 2 divided by 2 is 1. 8 divided by 2 is 4. Now my 3 outside numbers do not have a common factor, so I'm done. One more. So as we can see, sometimes students get a little tricked up. They see either the 5 and 10 have a common factor or the 5, 10, and 250. But if you don't see a number up front, we assume there's a 1. And the 5, 1, and 10 do not have a common factor. So we have to try to reduce the square root of 250 before we can do that common factor step. So I know 250 can be 10 times 25. 25 will give me a 5 times 5 pair. The 10 just gives me a 2 times 5. So it looks like with this one, I have a pair of 5s that can escape and a 2 and a 5 that will stay underneath. So 1, 5 dies, 1, 5 escapes. The 5 and 2 are both left, so that's just going to be on the square root of 10 still. And that's still all over 10. So now we only look at the outside numbers. We ignore the square root. What's the common factor? I can divide everything by 5. 5 divided by 5 is 1. 5 divided by 5 is 1. We don't touch the square root of 10 in this step. 10 divided by 5 is 2.